So supposedly if we have two sides OA and OB of unknown lengths intersecting at point O subtended by an angle theta, we can find out the unknown sides OA and OB using a mathematical tool called as trigonometry. Trigonometry basically deals with the length of the ratios of the sides of a right angle triangle to the angle theta. Now in order to make a right angle triangle, what we do is we drop a perpendicular OA on side OB. So we make a right angle triangle OAD, and we find out, since AD is known to us and angle theta is known to us, we can find out the unknown side OA. Similarly, in order to find out the unknown side OB, we can drop a perpendicular DB on OA and we can find out the unknown side OB. Now, in order to explain this further, I have taken a right angle triangle ABC on vertex B, and I have taken the angle theta, that is the angle of elevation, on angle C. So naturally, AB will be my opposite side to my angle theta. Similarly, BC would be my adjacent side to my angle theta, and the longest side AC would be my hypotenuse. Now in order to make certain trigonometric functions, we need to take the ratios of any two sides of these triangle. So what I have taken is, first I have taken opposite over hypotenuse, that is my side AB over side AC, and this corresponds to a trigonometric function called as sinusoidal or sine of theta. Similarly, my adjacent side to my hypotenuse, that is AB over AC, corresponds to a trigonometric function called as cosine or cos of theta. And the opposite side over adjacent side, that is AB over AC, corresponds to a trigonometric function called tan or tangent of theta. These three are the basic trigonometric functions which corresponds to certain ratios of sides of a right angle triangle. Now obviously we can take the reciprocal of this sine of theta, so we write it as 1 over cosecant or cosec of theta. Similarly, cos can be written as 1 over sec of or secant of theta, so sec of theta, and tan can be written as 1 over cotangent or cot of theta. So these 6 are basically the trigonometric ratios that we need to know. Now there's a very easier way to remember this by a mnemonics called as SOHCAHTOA, where S represents the sine and that corresponds to the opposite side, cos represents the adjacent side, and tangent or the tan represents the opposite side over the adjacent side. Now we can use this trigonometric functions to identify certain things. So for example, let's say we take a Pythagorean theorem. So Pythagoras theorem tells us the two side squares will be equal to the larger side square. So that is AB square plus BC square is equal to AC square for a right angle triangle. So what I have done is I have divided the AC square on the entire equation AB square plus BC square plus AC square. So what I have got is AB square over AC square plus BC square over AC square equals 1. But what is AB square over BC square? So if we look carefully, it is actually the opposite side square over the hypotenuse side square, that is sine square of theta. So I have written sine square of theta. Similarly, BC square over AC square is actually the cos of theta. So I have written cos square theta, and that is equal to identity. So this is one of the fundamental identities in trigonometry. So sine square theta plus cos square theta equals identity. So in this way, we can actually find out, without knowing the values of one of the sides, and if we know the value of or the angle of elevation or depression, that is the theta, we can actually find out the ratio of the trigonometric functions and equate it to a certain angle. This is where trigonometry is very powerful. It helps us understand the relation between sides and angles, and it's very much fundamentally used in architecture and other geometrical aspects in mathematics. It is also used in order to explain certain applications in physics, because obviously we are using some technological or mechanical things. So trigonometry is a very powerful tool in order to explain such dynamic situations, or in order to explain such constructions or certain amount of applications in mathematics.